Okay, so here are a couple more complex examples when integrating using substitution. So when I look at my first function here, e to the power square root of x over square root of x, that right there is pretty complex, and we want to use substitution here. Now, what do we want to use? What do we want to set u equal to? That's really the question here. So do I see a composite function here? And I see a composite function right here. Inside of that composite function is the square root of x. So square root of x is really x to the power 1/2. And when I take the derivative of that, I get 1/2 x to the power of negative 1/2. And that actually is the same thing as 1/2 times the square root of x. So outside of it, we actually get that derivative. So it actually does match this this pattern here. It's just a bit of an odd one. So we're actually using substitution here. So what am I going to let u be equal to? I'm going to let u be equal to the square root of x, which is really 1/2 x. So when I make that substitution in here, I get e to the power of u, and I'm going to try to get rid of the square root of x dx together and rewrite it in terms of u. Okay, so I need to rewrite dx over square root of x in terms of u. So where's that going to come from? It's going to come from the fact that I have to take the derivative of this with respect to x on both sides. So then I get du dx is equal to 1/2 x to the power of negative 1/2. 1/2. Okay, so I can actually rewrite this the right hand side. I get 1/2 times the square root of x. So where can I get this relationship somewhere in this expression? Can I play around with this somehow so that this appears? And yes, I can. What I will have to do is take the dx and bring it to the other side. So I get du is equal to dx over 2 square root of x. So I see it now. I see it here. Okay, but I don't like that 2 there. I'm going to bring it back to the other side. So I get 2 du is equal to dx over the square root of x, and I've achieved that. So I'm going to go back into here. I'm going to go the integral of e to the power of u. Dx over root x is really equal to 2 times du. Now notice everything is in terms of u now, and so really we're just integrating 2 times e to the power of u du. Now e to the power of u is a very special function. When you take the antiderivative, you actually get the same function back. So you get 2 to the power of u plus c. Now we make that substitution in for u. U, I believe, was originally x to the power 1/2, or the square root of x. It doesn't matter which way you say it. So I'm going to 2 times e to the power of x to the power 1/2 plus c, or you can write it as 2 times e to the power of square root x plus c. Either one works. Okay, so both of these are valid answers for this one. The next one I'm going to do in this podcast is just the one next to it right here. So sine squared x cos x. Now, does it follow this pattern that we want here? Identify the composite function first. So I see the composite function here, sine squared x. Now when I take the derivative of the inside function, now what is the inside function? I'm going to rewrite it like this: sine x all to the power of 2 cos x dx. When I look at the inside function, when I take the derivative of sine x, I do get cos x. So it does follow this pattern. So what I'm going to do is just erase this. Just get this. Actually, no, I'll leave it. I'll leave that. Okay. And I'm going to just use substitution now to integrate. So u is equal to the inside function. I'm going to use sine x for that. Okay. And I'm going to get du. Oh, actually, I'm going to get here on this side. I'm going to make that substitution for u. So u squared cos x dx. So I need to rewrite cos x dx in terms of u instead. So I'm going to take the derivative of both sides of this function with respect to x, and then I'm going to get du dx, oops, something went wrong there, okay, is equal to the derivative of sine x is cos x. Okay, so the idea once again was to get cos x dx somehow. So if I can get that from this expression by taking dx and bringing it to the other side. So du is equal to cos x dx. And now I can make that substitution in here. So integral of u squared cos x dx is equal to du. And now I can actually take the derivative from here. So I get u to the power 3 over 3 plus c, and then make that back substitution of what u originally was. Now u was originally sine x, so my answer is sine x all to the power of 3 divided by 3 plus c, or you can write it as sine to the power of 3 of x over 3 plus c. So that's how you do that question right there. It's almost a little easier than the previous one. So next podcast, we'll look at another trig integral.